You are tuned to Iri-e-learning and I am your host, Teacher. In this atomic structure lesson, we will focus on the structure of the atom. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to describe the structure of the atom and state the properties of the particles of the atom. But before we delve right into the lesson, let us do a quick recap of the definition of an atom, which was done in a previous video on elements and compounds. Remember, an atom is the smallest particle of an element that retains the properties of the element. So in other words, the atom behaves chemically just like the element. So just keep in mind that atoms make up everything around us. Now we can go ahead and examine the structure of the atom. Although atoms, as we just learned, are the smallest particle of an element that behave chemically like the element, the atom is in fact made up of three smaller particles that do not behave chemically like the element, and these three particles are collectively called subatomic particles. And the subatomic particles are protons, neutrons, and electrons. We will examine the properties of each subatomic particle later on in the lesson. As we describe the structure of the atom, we will start with the central structure and move outwards. The atom has a tiny, dense central structure called the nucleus. And the nucleus actually contains two of the subatomic particles. It contains protons and neutrons. The protons are positively charged, whereas the neutrons have no charge. The nucleus overall, therefore, will have a positive charge because the positive charges from the protons and neutrons having no charges at all, the combined effect is positive. Now, the particles in the nucleus, the protons and the neutrons, contribute to the overall mass of the atom. So the mass of the atom is concentrated in the nucleus because the protons and the neutrons contribute to the mass of the atom. Next, electrons. And the electrons orbit at very high speeds around the nucleus, and they do so on what we call shells or energy levels, some space that is located around the nucleus. Now, the number of shells that an atom would have depends on how large that atom is. So the larger atoms will have more electron shells on which the electrons will rotate or orbit the nucleus. Electrons are negatively charged and their mass is negligible. Now, the number of electrons on the outer shell of an atom will dictate the chemical properties of that atom, and we will just keep that in mind. We're not going to pursue that right now, but just keep in mind that the number of electrons on the outer shell of an atom dictates the chemical property of the atom. So just to summarize the structure of the atom, we have the nucleus, which is a tiny dense center consisting of protons and neutrons. Then we have the electron shells, also known as energy levels, which are the path on which the electrons orbit the nucleus. And of course, we have the electrons, and as we mentioned earlier, the electrons orbit the nucleus on these shells at very high speed. So to describe the properties of the subatomic particles, remember there are three subatomic particles. They are protons, neutrons, and electrons. And the protons and the neutrons are located in the nucleus, which is the central structure of the atom. Now, the protons have a relative charge of +1, so each proton has a +1 charge. And of course, protons contribute to the mass of the atom, and so it's assigned a relative mass of 1. Neutrons have no charge, that's 0, and of course, they also contribute to the mass of the atom, and so they have a relative mass of 1. And the third subatomic particle is the electron. And as we know, electrons rotate at very high speed on electron shells around the nucleus of the atom. Now, each electron has a relative charge of -1. And of course, because their mass is negligible, the relative mass assigned to each electron is 0. The relative mass of an electron is roughly 1 divided by 2000, which works out to be 0.0005 5. So if we are to round this value, we would end up with 0. Now keep in mind that the charge on the nucleus is always positive. Remember, the nucleus consists of protons and neutrons. Protons are positively charged while the neutrons have no charge. So the overall effect is that the nucleus will be positive. Note that the attraction of the positive nucleus for the negative electrons keep the electrons in orbit. Now the charge of an atom is always 0, and this is described as being electrically neutral. So atoms are electrically neutral because the number of protons always equal the number of electrons of the atom. So if you have 5 positive protons, then you would have 5 negative electrons, and their charges would cancel each other, which makes the atom electrically neutral. Lesson summary. So we have quite a few things that we have learned in this lesson. So let's just do a quick recap here. The first thing is that the 3 subatomic particles are protons, neutrons, and electrons. Next, the atom has high-speed electrons revolving around the tiny, dense central nucleus. And of course, the nucleus consists of protons and neutrons. The protons and the neutrons contribute to the mass of the atom, and protons are positively charged, electrons are negatively charged, and neutrons have no charge, so they are neutral. And an atom is electrically neutral because the number of protons equal the number of electrons. Are you ready? It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. What is the center of the atom called? A. Proton, B. Element, C. Nucleus, D. Neutron. The answer is C. Nucleus. The center of the atom is called the nucleus. Question 2. Name the 2 subatomic particles located in the nucleus of the atom. A. Protons and neutrons. B. Neutrons and electrons. C. Protons and electrons. D. None of the above. The answer is A. Protons and neutrons are located in the nucleus of the atom. Question 3. Which subatomic particle revolves at high speed in the space around the nucleus? A. Proton, B. Electron, C. Neutron, D. All of the above. The answer is B. The electrons revolve at high speed in the space around the nucleus. Question 4. What is the relative mass of an electron? A. -1, B. 1, C. +1, D. 1 divided by 2000. The answer, of course, is D. 1 divided by 2000, which equals 0.0005. And if we were to round that, we would obtain 0. Question 5. Identify the statement that best explains why an atom is electrically neutral. A. The number of protons and neutrons are equal. B. The number of protons and electrons are equal. C. The number of protons are greater than the number of electrons. D. The number of protons are greater than the number of neutrons. The answer is B. The number of protons and the number of electrons are equal, which makes the atom electrically neutral. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.